Okay, let's go directly for the solution for this exercise. So first of all, we calculate the reactance for the G1. So how to calculate the reactance for the G1 is X G1, and because the value given is 15%, so this is a 15%, the percentage is here. And then the base MVA we already know, which is 30, and then the MVA for that G1 is 20 MVA, and then we get the answer of J 0.225 per unit. This is per unit. The same case, just the value is different. So for the G2 also, we replace the 10% here, okay, the 10% here, and then the base given for the G2 is 10, then you get this value. Okay, for the transformer, the same concept, okay, so 5% is given, but the MVA is same with the base MVA for the question, so 30 over 30 become 1 and get the J 0.05. Okay, next is the about the impedance. So we need to find the line impedance per unit. So the given value, if you check from here, the given value here, so the given value is 3 plus J15 ohm. So this is the line impedance given, but we need to find it in a per unit. So the Z line, so the line impedance is 3 plus J15 ohm. Then we need to find the Z base first. Z base. So the base impedance here is a V base multiplied by V base over the S base, where the S base is 30 MVA and a V base given in the question as 33 kilovolt. So this is the V base, okay, V base. Then we get 36.3 ohm per unit. Then finally we found, we solve the line impedance per unit, so line impedance per unit, which is 3 plus J5, Z line. So Z line over Z base, or written here. Z line over Z base. Sorry for my bad handwriting. Okay. Then finally we get this 0.0826 plus J 0.4132. Okay. Now what's next? What we are going to do is we want to simplify the circuit. Okay, simplify the circuit. Okay, right now we don't have anything, so that's why we need to write. So first of all, we know that we have 2G, so G1 and G2. Okay, so this G1 and 2, they have XG1, so this is the XG2. Then after that they have the transformer reactance, the reactance for the transformer. Then finally we get the line impedance. So line impedance, you write this is the resistance. Okay, and another one part, the complex one, is the reactance. So basically this is it. So we have the G1 here, so G2. So this is apparently this is the XG1, and this XG2, and this is XT, and this part is the PU line. Okay, PU line, ZPU line. Okay. Then we simplify it. Okay, we simplify it. Next, we can do like this. Okay, this. So we have the okay. Then we have the transformer part. Then again we have the resistance and also the reactance for the line. Okay. So I just simplify it, just become like this. Then what should we do next? You know already, because this is parallel. So parallel means that so XG1, XG2 lah. So this is the XT, and this R. Okay, this R and X for the line. So line, R line, and R and Z line. So here you can understand that this is the parallel, and this both can also be added. Can be summed because the series, this is series. So we just simplify it like that. So at the end, basically the idea is become, so this is the xg1, xg2, then you have the R line, so R line, and the one, this is the sum of the xt plus x line, okay, line. Okay, just the basic idea. Okay, this is very basic. This is what we call the Thevenin. So because I don't remember the values, so I will continue with the slide that have the value lah. Okay, then we get the ZPU. So finally we get the ZPU lah, after consider all these things. Okay, after consider all these things, so you need to replace the value. Here I don't have the value, so I forgot. So you just replace your value. Okay, replace your value. So after that, you get the ZPU. So you get the Z4 PU, which is the finally. So this is all the sum for the reactance. Remember, where does it come from? It's come from the xg1, xg2 plus xt plus x line. Okay, x line. Okay, the reactance, the line reactance. Okay, then you get change it in the phase. Okay, phase mode. So you get the magnitude and the angle. Then after you get the ZPU, then you can easily calculate the Z fault. So where the Z fault, also called as the MVAF. Okay, MVAF. So it means that fault as fault. Okay. The equation is very simple. So this is the MVA base given, which is the 30. Then this is the value that we obtained from the Thevenin technique base to sum up all the per unit impedance. So this is the value we get. Then you get the S far as 50.21 MVA. Then next, because we need to find the fault current, so we have to find the fault current lah. So IF, fault current is IF. Then you just divide the S fault that determined here. Okay, this S fault. So over the root 3 multiplied VL. VL, remember this is the V base, which is the 33 kV. Then you get, this is the final answer. So this is the answer. Okay, all right.